Okay, so if I asked you to, picture the titans of astronomy, who comes to mind? The absolute Hall of Fame.
Well, you're probably thinking of the usual suspects, right? Galileo, Copernicus.
Exactly. Galileo with his telescope, maybe Isaac Newton and that apple. It's the standard story we all learn.
It is. And they were brilliant, no question.
Right. But what if I told you that centuries, in some cases a full millennium, before any of them, sages in India were already calculating the circumference of the Earth?
And not just that, the nature of gravity, and this is the one that always gets people, the speed of light.
That's the premise of our deep dive today. We're sort of bridging two worlds that feel miles apart.
The ancient chants of the Vedas on one hand.
And the high-tech rockets of ISRO, the Indian Space Research Organization, on the other. It sounds like a total contradiction.
It does, mantras and moon landings. But what's fascinating is that it's actually, well, it's a continuous story.
A continuous story of what?
Of the intersection of philosophy and mathematics. You see, in the West, you had science and religion, often, butting heads. Galileo on trial.
Of course. Heresy.
But in ancient India, looking up at the sky wasn't just science. It was a way of understanding existence itself.
Okay, so let's unpack that. Because I think of ancient sages and I picture meditation, philosophy, not trigonometry. Why do they need such hardcore astronomy?
The why is everything, and it comes down to one word: time.
Time.
Yes, time was everything. Society revolved around rituals, these yajnas or sacrifices, and the timing had to be perfect.
So you couldn't just say, let's do it around noon-ish.
Oh, absolutely not. The texts are incredibly specific. If you wanted rain or prosperity, you needed to know the exact position of the sun, the moon, the constellations.
If you were off, the ritual was void.
Exactly. The stakes were incredibly high.
So astronomy basically started as like a high-stakes calendar app for priests.
That's a great way to put it. A very modern way, but yeah. And this need gave birth to something called the Jyotish Vedanga. It's one of the 6 limbs of Hinduism, designed specifically for tracking celestial bodies. It was rigorous, mathematical observation. You had to calculate it.
And this goes way back. I was reading that even the Rig Veda has verses that track solstices.
Correct. But there's another layer here, and this is what really separates it from, say, the Babylonians or the Greeks. It's how they saw time itself.
Right. I'm used to time as a straight line. Past, present, future. A to B.
That's the linear view. The Indian view was cyclical. They thought in yugas.
These vast cosmic cycles.
Exactly. Time as a wheel, constantly turning, destroying, and recreating the universe. So they had to get comfortable with enormous numbers.
Numbers that just make your head spin.
Right. While some cultures thought the world was a few thousand years old, Indian cosmologists were dealing with billions of years, which, happens to align surprisingly well with modern cosmology's estimate for the age of the universe.
Just a different scale of thinking.
It is. When your philosophy demands it, your math has to rise to the occasion.
Okay, so they had the motivation, the rituals, and they had the philosophical scale. Let's talk about the people who actually did the math. The Indian Einstein.
Aryabhata.
Born in 476 CE. I did the math on that. That's 1,000 years before Copernicus.
A full millennium. And in his book, the Aryabhatiya, he makes some claims that are, well, frankly, revolutionary.
Like what?
First, that the Earth is round, spherical, but more importantly, that it rotates on its axis.
Okay, we have to stop there. Because the common sense view is that we're still dead and the sky moves. How on earth did he explain this to people in the 5th century?
Well, he used this beautiful, simple analogy. He said, imagine you're in a boat on a river.
Okay, I'm in a boat.
As you float along, the trees on the bank, they look like they're moving backward.
Right, volative motion.
Exactly. So Aryabhata said, just as the person in the boat sees the stationary trees moving backward, we on the spinning Earth see the fixed stars moving westward.
It's not the stars moving. It's us.
It's us. It's such an elegant way to explain a really counterintuitive idea.
It really is.
Yeah.
And he didn't stop there, right? He also tackled eclipses.
He did. Now, the mythology at the time involved demons, Rahu and Ketu, swallowing the sun.
Which is a great story.
A fantastic story. But Aryabhata was a scientist. He said, no, it's not monsters, it's just shadows.
Shadows.
A lunar eclipse is the Earth's shadow falling on the moon. A solar eclipse is the moon's shadow falling on the Earth. Simple. And here's the kicker.
What's that?
His calculations for when these eclipses would happen, they differ from modern calculations by only a few minutes.
In the 5th century.
Yeah.
without a telescope.
Minutes, just pure mathematics and observation.
That's astounding. So we have a spinning Earth, we have eclipses, which brings us to gravity, and Newton's apple.
The famous apple. Look, Newton gave us the universal law, the math to predict it. But the concept, the idea that the Earth pulls things toward it.
That was around earlier.
Much earlier. We have to look at a 7th century mathematician named Brahmagupta, still 1,000 years before Newton.
Okay, what did you say?
He used a specific Sanskrit term, Gurutvakarsan.
You have to break that down for me.
Sure. Guru means heavy, or master, and akarshan means attraction, a pull.
The attraction of the heavy thing.
You got it. And he wrote, bodies fall towards Earth as it is the nature of Earth to attract bodies. And then he adds this crucial part, just as it is the nature of water to flow.
Huh. The nature of water to flow.
That phrase is key. He's identifying it as a fundamental property of the Earth, an inherent force of attraction. He didn't have the equation, but he had the concept down cold.
That's incredible. But
Yeah.
okay, I have to play the skeptic for a minute.
Please, it's healthy.
I can sort of see how you can figure out rotation and even gravity through observation over time, but there's one claim in our notes that just seems impossible.
I think I know which one you mean.
Speed of light.
Yes, that's the one that usually stops people in their tracks.
I mean, to measure that, you need lasers, atomic clocks, You can't just use a stopwatch on a sunbeam. It's roughly 186,000 miles per second.
Ow. This is where we have to look very carefully at the text. We're talking about a 14th century scholar named Sayana. He was writing a commentary on the ancient Rig Veda.
So he's interpreting a much older text.
Exactly. He's looking at a verse praising the sun, and he writes this specific line of commentary. Tatha chasmarya yojanam sahasra divi shat divi sayojan ekina nimishardniya kramamana.
Okay, that's a mouthful. What's the translation?
It translates to, it is remembered that the sun's light travels 2,202 yojanas in half a nimisha.
2,202 yojanas in half a nimisha. Sounds like a math problem.
It is a math problem, and we can solve it. A yojana is an ancient unit of distance, roughly equal to about 9 miles.
Okay, so we have the distance. What about the time, a nimisha?
A nimisha is a unit of time, literally a blink of an eye. Half a nimisha works out to a very specific, very tiny fraction of a second.
So you take 2,202 yojanas, multiply by 9 miles, and divide it by that fraction of a second.
You do.
And what number do you get?
You get a number that's approximately 186,000 miles per second.
No way.
Yeah.
Wait, 186,000. The modern value is 186,282.
It's shockingly close, terrifyingly accurate, as you said.
So, was it a coincidence? A lucky guess with the units?
That's the billion-dollar question, isn't it? We don't have the workings written down. We don't know the method. But we have the number written in black and white centuries before anyone in the West measured it.
It just makes you wonder what else we've lost.
It does. But it wasn't all just in books. We have physical proof of this obsession with calculation.
You're talking about the observatories, the stone calculator.
Exactly. Take the Konark Sun Temple in Odisha. It's designed as a giant chariot, and the wheels.
The wheels are sundials.
Not just sundials, but incredibly precise ones. You can tell the time down to the minute just by seeing where the shadow falls on the spokes.
And then you have the Jantar Mantar.
The Jantar Mantar observatories from the 18th century, I mean, they look like giant abstract sculptures.
I've been to the one in Jaipur. It feels like a skate park for giants or something.
That's a perfect description. But every one of those curbs, every staircase, is a calibrated astronomical instrument. The big one, the Samrat Yantra, is 90 feet tall.
And it can measure time to an accuracy of what?
2 seconds.
2 seconds.
Yeah.
From a block of stone.
Its shadow moves at about a millimeter a second. You can literally sit there and watch the Earth turn.
Which brings us all into the present day. We started by talking about ISRO, the Indian Space Research Organization. There really is a direct line here, isn't there?
There absolutely is. It's the same spirit of calculation. Just look at their Mars mission, Mongolian.
The one that was famously cheaper than the movie Gravity.
That's the one. And how did they do it so cheaply? Not by cutting corners, by using better math.
The slingshot technique.
Exactly. Instead of using brute force, a giant rocket to go straight to Mars, they used Earth's gravity to fling the spacecraft.
So they used the Gurutmakarshan that Brahmagupta was talking about.
They literally did. They used the universe's own forces to do the heavy lifting. It was a triumph of calculation over raw power. Cosmic judo, as you said earlier.
That is just a perfect connection.
It is. From an ancient text on planetary positions, the Surya Siddhanta, to the control room landing a rover on the south pole of the moon, It's proof that this has always been a civilization of stargazers.
It really reframes the whole history of science. It wasn't just Europe waking up while the rest of the world was, asleep.
Not at all. Knowledge is a global heritage. And what's amazing here is how they never saw a conflict between the spiritual and the scientific.
Understanding the math was a way to understand the divine.
Precisely.
So we've gone from priests, timing rituals, to Aryabhata spinning the earth, to a 14th century scholar writing down the speed of light, all the way to landing on the moon.
It's quite the journey. And the common thread is just looking up and asking, how does that work?
It makes you wonder what knowledge is still out there, hiding in plain sight in some old text.
And that's the most exciting part. For this entire lineage of thinkers, from the Vedic sages to the ISRO scientists, the sky was never the limit.
It was just the beginning.
It was just the beginning.
I love that. Well, that wraps up our deep dive today. It's been a real pleasure.
It has. A good reminder that science has many, many roots.
For everyone listening, if you enjoyed this little time travel journey, please share it with a friend. And, as always,
Keep questioning.
and keep looking up.